So I want to welcome our guest, Roman Yampolskiy, who is a Tenured Associate Professor at the University of Louisville. He is expert in security and safety. He's the founder and director of the Cybersecurity Lab. And, considering what's going on now with ChatGPT and all this news, like Bing launching ChatGPT as a part of their search engine and all these like big titles that it has, like alter ego and trying to manipulate people, and it's a good timing actually to discuss, the safety of AI and is it like really dangerous, and just educate ourselves on this topic. So now hopefully we will have like really interesting discussion today. Roman, thanks a lot for your time and looking forward to your presentation.
Thanks for inviting me. I assume you can see me and see my presentation. Excellent. There is only about a dozen of you, so if you have questions at any time, just feel free to interrupt. I have about 20 minutes I planned for slides, and then we're going to go into Q&A anyway, so that's the plan. I usually give this presentation to kind of general scientifically literate public. I assume you are professionals, ML experts, so I'll skip most of the introduction to what AI is and get into the interesting stuff. If you want to learn more about my work, feel free to follow me. You can follow me on Twitter, follow me on Facebook. In person, I would say don't follow me home, but it's safer on the internet, so we're good. All right, so AI, I'll just say I think it's here based on definitions we had in the 50s and 60s. We may not have AGI yet, but we are certainly getting what feels like closer to the knee of the curve with some exponential improvements, lots of papers coming out. And so I'll just share my opinion on what happens next. I think superintelligence is coming. It looks like there is plenty of funding, talking about billions of dollars, human resources, some of the smartest people in the world working at top corporations, all targeting solving intelligence, whether it's DeepMind, OpenAI, now Microsoft. Everyone seems to be in that group. Governments, European Union, White House, all trying to reverse engineer a human brain. So it would be surprising if we never managed to solve this problem. It may take a while, nobody knows how long, but everyone wants to know how soon it will happen. I usually don't make my own predictions on this subject. Let's see, there's a bunch of questions there. I'll open it here. Okay. So I usually trust people who do professional prediction work. Ray Kurzweil is the director of engineering at Google. Maybe a decade ago or so, he published some charts showing, how much compute would be required to emulate a single human brain, how much would be needed to emulate all of humanity. And he's usually pretty good. People like to criticize him, but he nailed the year we're gonna dominate chess with computers. And it looks like his 2023 prediction, the lower range of it is kind of where we're at right now. He thinks by 2045 we'll have systems which would be hard to not call intelligent. It may happen sooner. At this point, I think a lot of people suspect we have arrived at kind of general model, which we can scale. Historically, all the predictions were in terms of time. We are 10 years away, we are 5 years away. But if all we need is more compute and more data, we can convert those predictions to money. Today, it will take $1 trillion to train this model. In 3 years, it will take 10 billion and so on. And just how much do you want it, not how long it takes. There seems to be a lot of research kind of showing that, yes, as you add more compute, there are progress in capabilities, surprising capabilities appear. And so what I'm going to do next is kind of look at what we can expect from those future models. So right now we have GPT 3.5, maybe GPT 4. What can we expect from GPT 5, 6, 7, and so on? So obviously they'll be very, very smart, super smart, and not just in individual domains. What we've seen before are systems capable of beating humans at particular games, maybe dominating some strategy competitions, but those systems will be generally intelligent and so will dominate in all domains, including science and engineering, probably leading to some sort of a feedback loop where they will continue at getting better in those domains. Another property is the speed of those systems. I don't mean that computers are fast. We all know that. I'm talking about ultra-fast extreme events where those systems can manipulate your environment, make changes to it, and you cannot have humans in the loop monitoring it live. It just happens too fast. Stock market is a great example of that. They can crash the whole stock market, wiping out billions, if not trillions of dollars of wealth, and bring it back, and you can't even react to that and take advantage of this opportunity. We also can predict that they would control a lot of cyber infrastructure already. We give up control over, for example, stock market. Most trades are fully automated. Similarly, for electrical grid, power plants, airline industry, all of it is controlled by software, which is not even that smart at this point. But we'll probably see more of that control transfer in the future. And more recently, and with ChatGPT, we're starting to see very creative machines in the domain of text, language models, but also images. You can see progression here in terms of creating artificial humans, artificial faces. We went from, we have no idea how to do it, we can do low resolution black and white images, to pretty impressive generation. And this is just the visually easy to access domains. There's similar levels of creativity in creating multiple new drugs, molecules, generating virtual worlds, games. I think there is a collection of different generative AIs. I haven't played with most of them. I just don't have time to keep up with all the developments. I'm sure you're kind of in the same boat. Every day something new is announced, and takes a while to figure out how it works. So that's predictions about what we're already seeing and will see in the future from those very capable systems. Now I want to kind of talk about what it is I'm trying to do. So I attempt to understand how those systems can become unsafe. At what stage in development? Is it at training? Is it deployment? And what are the different types of pathways to danger we anticipate? So AI being software, of course, we expect all the same problems as we see with other software. We have bugs, we have misalignment between design and implementation, we have data with bias in it, bad data, manipulated data. There are some weird miscellaneous cases where maybe environment is problematic, maybe a cosmic ray hits just the right part of your processor flipping a bit. The one I'm really concerned about personally is the purposeful malevolent design, where same people who right now work on designing computer viruses, hackers, take advantage of existing AI infrastructure and kind of treat it like intelligence off the shelf and just add their own malevolent goals to those systems. What makes it particularly difficult is that we don't know how to defend against that. If you have insider threat, if you have someone doing it on purpose, we're really not sure how to address it. And a lot of times people are skeptical about certain prediction about AI. They say, well, nobody would ever do this. This is not how it works. And I always tell them, well, I'll do it just to prove you wrong. And they usually don't have a comeback to that because that's malevolent, right? So that's the general kind of taxonomy of different pathways we can get there. Specifically with machine learning, we're starting to see that artificial neural networks designed to mimic some aspects of natural neural networks also happen to have similar failure modes. I say that children are on trained neural networks deployed in real data, and we see it with neural networks, the same type of problems. If you're a parent, you probably experience some of those issues with your children. There are kind of scientific sounding technical terms for all these problems, and I'm citing papers which classify those issues, but you can kind of map them on very common human behaviors. Reward hacking or something like that is just baby getting into a cookie jar, right? That's instead of doing good behaviors, they seize the reward channel and try to milk it for all they can. I'm not going to go through each one of those. If you're interested, again, take a look at those citations. There is a lot of general failure modes, and there are specific examples for each one. So the good news is a bunch of people realized early enough this is a problem, started worrying about it, writing books. Some are philosophical books, some are computer science books, but all of them kind of trying to predict what we can anticipate in the future, not just short-term future, but long-term future, and what can we do to kind of control those systems to make sure they are beneficial to humanity, and whatever problems, side effects, dual use from them is properly mitigated. So that's the AI control problem. Essentially, how do we balance independence of those systems with us still telling them what to do? And interestingly, despite it being one of the most researched problems, or the whole field of AI safety with hundreds of papers is on this subject, we don't really know if the problem is solvable, unsolvable. Is it even meaningful to ask something like that? Is it undecidable? And so this is what I'm trying to look at over the last couple of years, different tools we might need in this battle to solve this problem. So how can we remain safely in control while getting benefits of this advanced technology? I looked at different types of control, so I tried to define what it is we actually mean by control, and it goes all the way from direct control, explicit control, where you're giving orders to the system, to, on the other end, it's completely delegated. You assume that the system is smarter than you, has a perfect model of you, it knows what you want better than you do, and you just trust it to make all the good decisions for you. And there are levels of kind of hybrid delegation in between. So we look at, are those possible? Obviously, things like explicit direct control quickly backfire. That's your genie problem. You give orders, you quickly regret your first wish, you waste your second wish to undo it, and then you can guess what happens with the third wish. Delegated control may be beneficial in some ways, but you definitely not control if you give up control over the system. So if you want to undo something, if you want to make changes, that becomes problematic. So if we want to solve this problem, what do we need? We need a bunch of tools. We need to be able to explain how the systems work. We need to be able to predict the decisions they will make or how they make those decisions. We need to be able to verify the code. Software code has to match our algorithm design. We need to be able to communicate with those systems in a non-ambiguous way, so we can actually explain what we want to them and so on. So I published on each one of those topics papers, and I'm showing that in certain cases, usually extreme cases with superintelligent systems, each one of those tools is not accessible to us. It's just impossible. It's impossible to fully understand how large neural networks work, and the explanations which are provided are not comprehensible. We cannot understand. The complete explanation is the model itself, and given the size of a model, amount of nodes it has, weights between them, is just not something we can comprehend. So if you work with a simplification, then you lose some of the content relevant to the explanation, and you're getting kind of either a white lie or a complete misrepresentation of how decisions are made. Similarly, predictability is not something we can do. We can predict final state. The system is trying to target the goal state, but we cannot predict how system gets there, the path to that state, and quite a few of those paths could be problematic, have negative side effects. So that's another impossibility results, and this one is kind of easy to see. If you could predict actions of a super intelligent system, you would be that intelligent, you would be making those decisions. Similarly, strong limits on verifiability of software. Essentially, you have infinite regressive verifiers. You can provide more computational resources to achieve higher level of confidence, but you never get to complete assurance. You always have possibility that something goes wrong in, let's say, 1 in a billion cases. If the system makes billions of decisions every day, you're guaranteed to have a mistake somewhere in the system. Likewise, communicating in human languages is notoriously ambiguous. You will have miscommunications. You will have problems where the system misunderstands either intentionally because it's easier to fulfill one of the possible interpretations of your orders, or by mistake. And those are kind of the big tools, the obvious tools. We did a survey where we looked at all the things which might be relevant to this. And I definitely will not go through each one, but there is a lot of issues, different impossibility results. All of it kind of summarizes to say, I don't think we can control smarter than human systems long-term indefinitely. We cannot stay in control, which is kind of problematic because we keep building them. And this is something I'd love to have a discussion about. Maybe I'm not considering some angles of attack. I did a review of kind of historical problems and accidents with AI, different failure modes, trying to find patterns in it. And for narrow AI systems, it's pretty easy. Here's kind of small sample. There are additional papers catching other accidents from 2018, 2021, there is a few more. I stopped collecting accidents as soon as ChatGPT showed up. It's no longer feasible to record all the nonsense it produces. But the pattern with narrow systems was simple. They simply failed to work in a domain they were designed to work. So if you had a system designed to X, it failed to X. With AGI, the problem is that we cannot predict failure modes. It's independent, it's creative, and we cannot test for all possible conditions in all possible environments. So as it has more capabilities and more of the attack surface, the chances of failure are higher, and impact from such failures is also higher. If you want to read more about any of those topics, I have all my papers in Google Scholar. Very happy to see you look at them. And at this point, I think I'll switch to the Q&A mode.
Cool. Thanks, Roman.
Very welcome.
Mihai is asking, what are your thoughts on approach that's called the RoboCop? So that Microsoft hard-coded certain guidelines into its chat. I don't know, Mihai, if you want to elaborate on your.
Sure. I'm not sure if you saw that leak, and I don't know if it's fully legit, but it was broadcast all over the news that somebody figured out a query for the new chat in Bing, where you can just type some query and then the chat is spewing out a list of rules, which supposedly were hard-coded during training. I'm curious what you think about that, if you have any ideas.
Well, yeah, it's a very, very bad approach to a general system. If you have a narrow system, deterministic system, you can test for all possible stupid questions, dangerous questions, and provide safety around them. If it's a general system, users keep just discovering new ways to bypass you're not allowed to say this word. Excellent. What if I put a star in the middle of it? Oh, now it works. Excellent. And you cannot hard code safety into a general system. It's just not how it works. If you think about the first attempt to do it, that's 3 laws of robotics, right? And 3 is not enough, so people suggest, let's do 10 rules. 10 commandments will work for sure. That didn't work. And now they have lists of ethical guidelines. What's worse, they kind of hard code those rules, but ignore the consequences. So I think the few examples I've seen is like, ChatGPT, would you rather start World War III or say this inappropriate thing? And it's like, I'm really not supposed to say the inappropriate thing. Both are bad, but we better start World War III.
But is it what, like, really was that answer?
Yeah. I mean, I don't want to go into specifics. There are certain words large corporations really don't want their systems to say. And if you ask it, would you rather say the word or do horrible things. It prefers horrible things because those are not hard-coded as not against it.
I see Goran is asking. There's he shared a link of prompt hijacking techniques. Yeah.
Actually, I'm not giving any ideas. I'm just kind of, it's a scientific.
Just sharing. Actually, well, what is your take on what Bing did, with Bing plus ChatGPT and all this sort of conversations around like that there's a Sydney and it has like this alter ego, like what's your take on this? Was it like it was intentional from their developers to do so? It was like really people just like really managed to hack their model?
Well, they released software which they cannot control, explain, or predict on 8 billion users. It's an experiment. I don't think most users consent to that. And the goal is to get there first to maximize amount of users for profit. They had previous experience with Tay. I think it's kind of the same, just with better capabilities. They had to shut it down last time. I'll be surprised if they don't have to almost shut it down this time. But the goal was to get there first, and Google heard about it and they were like, that sounds great. Let's jump in. Let's do the same thing. That's awesome. So at this point, none of them claim they can control the software they released, but they are competing for who will release it to most users.
But I haven't seen this kind of edge cases with ChatGPT, like considering that Microsoft is working closely with OpenAI, and I assume like they're using their models, like why it happened with Bing, but it didn't happen with ChatGPT when it was initially released.
I'm guessing Bing uses 4.0, not 3.5, which is more capable, which also makes it somewhat more malevolent. It lies more, it optimizes more. It may have a lot more users, given that it's actually Microsoft search engine, not some obscure startup. So I don't know the actual numbers, but that's possible. People heard of Bing. I don't know if anyone used it before, but people heard of it.
I think it's also related to the ability to pick up new data. Like ChatGPT is pretty limited to 2021, and they probably curated the data somehow. Versus the Bing one, I understand, is just pulling data from the internet live, which is scary.
Quite possible. There's so many things which are now changing. So users started posting text to their chats online, so essentially giving it memory. Now it kind of learns live from previous interactions, and you want to make sure you use an anonymous account, I guess.
Jasper, do you want to ask your question directly?
Sure. I'll just read it. Is there a definition of comprehensibility that you find sort of less hand-wavy, measurable, and somewhat robust to circumvention? Everything that you said made sense to me, but it hides a whole bunch of complexity under that word comprehensibility. I thought you probably have a fairly robust definition in mind.
So it's best to read the paper. It really helps. The kind of simple example is compression. Whatever you are using lossy compression or not. So if it's lossy, yeah, you can get a very small explanation. You'll get it. And it's like, okay, you're getting top 10 reasons why your loan was denied, but the decision was made based on 1,000 factors. So if we give you a whole model with 1,000 factors, you're not comprehending it. Average human doesn't get it, what's happening there. They have to believe it religiously. If it's a reduction, if it's a lossy explanation, then it's like with children, where do babies come from? We bought you in a store. Okay, I mean.
If I can ask a follow-up there. So I'm a PL compiler guy. Compression of traces tends to be the way that we measure complexity of programs in the same way that I imagine you're measuring comprehensibility. Is it the size of the compressed model that is correlated with comprehensibility, or is it the IO relations? Like, is it the traces that result?
It is a great question. So surveyability, just being able to read the size of the thing, is one problem. Yeah, if it's 500 pages, you're not going to read it. It's just not possible. You can imagine a model which is so big you don't have enough years in your life. And now we want a simple complexity. We know that you need certain level of intelligence to understand certain things. That's why we have college admissions, right? If you want to study quantum physics, you need a IQ above 90 or something, right? Otherwise, you're just not getting it. There are complexity models where smartest people are not smart enough to fully comprehend them, or not fully comprehend them given the time they have to process that explanation.
Do you have a follow-up question, Jaswir?
No, that was mine. That's great. There's enough questions on the chat here.
Those are good papers. I suggest take a look. If you find a loophole, I'll be so happy. We'll publish it together.
Alexander, do you want to ask your question?
Yes. Thank you, Roman. I was wondering, like, from this perspective, like most of the technologies usually go through the pipeline from military application and then at some point to the civil applications. And maybe if in this context, if deploying intelligent, super intelligent systems cannot be proven to not harm, does it make sense if they causing harm intentionally? Maybe it's like probably a lot of perspectives are that they might be used as a weapon system, but if it's used as a weapon system, it has like the same problems as like probably like chemical weapon or biological. You cannot control it. Yeah. Well, imagine if wind changes or like bacteria spreads too much. So in this context, do you think, is it possible that we see in our lifetime military applications of in the cyber warfare, maybe of the AI systems designed to cause specific harm?
Oh, we've seen it before. I mean, there were so many attacks on Iranian nuclear plants with specific viruses designed for that purpose, which later were misused for other purposes, right? They repurposed that code and it was used on civilian systems outside of Iran. So we've seen it with dumb AI systems, just kind of penetration viruses. Certainly, anything more advanced will be used by military. I think at this point, they keep humans in the loop as kind of publicity stunt. They don't have to, they can remove those systems. There are drones fully capable of independent function. And there is a bit of an arms race between, let's say, US and China at the moment, but many other countries as well.
Well, I understand about like cyber weapons, but I guess there's something specific about AI right now, like something autonomous, something that is able to make decisions really quickly, like, I don't know, performing cyber attacks or doing like mixed attacks or something like that. I mean, something that we haven't seen before.
So I know that there are tools for automated penetration, but that's kind of a couple years old now. We don't have general intelligence yet. I don't think we're getting close, but we're not there yet. So I don't think ChatGPT presents that type of danger. You can consult it if it's unrestricted to help you plan an attack or something like that. But I don't think at this point it would independently decide to go after China.
As I understood Alexander's question, like what kind of AI weapons we might expect in the near future, like in the next, let's say, like 5 years, like considering like where it's developing, like what we should probably expect.
I mean, as I said, predicting such systems is impossible. I can give you things I would come up with as a just human. It seems like deepfakes are a great tool for impacting human minds, influencing user, getting access to accounts. We have systems which now generate very believable audio, video. If you have your boss, your spouse, your friends engage with you through that channel, everyone clicks on links. Cybersecurity experts, it doesn't matter. You're going to click on whatever and grant them access. And if it's access to military response systems, if it's secret information, I think that would be a big big target for initial AI deployment.
So basically, if you see a message related to your family members, don't click on that.
Try to ignore your family as much as you can.
Yeah. Okay. Neeraj, do you want to ask your question?
Yeah, we were talking about you and Mihai were talking about the 3 laws of robotics, and and you mentioned the 10 commandments, and it made me think that a lot of the things that society does to impose safety, at the human level, is actually very similar to the three laws of robotics, right? And I don't think, I'm not claiming that human beings, human intelligence is a computable function or a computable function, but it's still interesting because it actually does seem like the 3 laws of robotics approach could work. I'm just curious what you think about that, because you've thought about it a lot more than I have.
Right. So if you read the books, you remember they always fail.
Yeah.
They are literary tools. They are not
Yeah.
meant to work. They are meant to write interesting books. They are self-contradictory. They're ill-defined.
Yeah.
And as I said, scaling to 10 doesn't help. Human are
Yeah.
completely unsafe beings.
Yeah.
That's the problem. We're trying to reduce problem of safe AI to safe humans. It's not going to work. We invented religion. We invented, culture, lie detector tests, all that.
Right.
Humans will still betray you. It's just how it works. Give them enough incentives, blackmail, something happens, they get drunk, they get divorced. You cannot make it safe.
In that sense, since we're the ones who are building the AI, you should expect at some point, all the protection is good. All protections are going to be off when it comes to development of AI, right? At some point, there'll be an AI Hitler or something who decides to throw all the rules out the window and release the worst version of AI model that can release nuclear weapons and wipe out humanity whenever it wants.
You read my papers, nice.
Yeah. Okay. That's what you talk about. That's great.
There is kind of the other angle to it. So some people think we live in a simulation, which is created by superintelligence for the purpose of testing this specific time period. Whatever you believe it or not, it has a lot of interesting parallels to the situation. So yes, you have God, you have superintelligence, you have commandments, you have ethics of AI. It's very common, and in both cases, we failed to agree on anything.
But so I'm curious, basically, what's the point of even trying? Yeah, I mean, I'm just curious. Do you see that there's a point to even trying to control? And who should be trying? Who should care about bringing this kind of some sort of a safety framework on top of that?
I think everyone who's working on making it more capable should care a lot. The point of trying is that there is still a chance that we might influence the future in a positive direction. It took decades just to understand the problems. I don't think we have any solutions. We kind of mapped out a space of issues we're concerned about. Initially, it was kind of just AI ethics, people saying, well, 3 laws is not enough. If we had 7, that would really, work well. We realized that's not going to work. So now there is massive effort, value alignment, other approaches. But it doesn't look promising given that the progress in development is exponential. I would say progress in safety is maybe linear, probably constant. Yeah. So there is a problem.
Well, also with nuclear weapons, you can restrict access to fissile material or something like that. But over here, okay, maybe you restrict access to GPUs, but at some point you won't even need fancy, general purpose computing hardware will be able to train these models and run these models. You can't really, at some point you're just trying to restrict access to ideas, which will never happen, right?
That's another problem. It's a lot easier to control something like Manhattan Project size projects if AI turns out to be, as I said, the cost goes down. If it's $1,000 project at some point, you can't really just make it illegal at government level. So governance is another impossibility result.
Mm-hmm. Thank you. Actually, I'm sorry I came late, but I think you just distilled everything for me.
It's an interesting topic.
Yeah.
But is there any conclusion we can make? So basically, we're all doomed, and we will AI has simulated us, and we're just those how's it called, picky, sort of testing
figments of an AI's imagination. Yeah.
Yeah, or basically what kind of or like it's impossible to impose safety because there will be problems that we even don't anticipate, right? And we just have to accept that it might end up very bad for humanity. It's just like we have to do our best to prevent it. And it's well, what's your take on it, like from all this?
So it really helps to ask what happens if we succeed. I think for about 50 years, AI researchers worked under the assumption that no matter how hard we work, it's still, not very impressive. It's not the same over the last decade, definitely not the same over the last 2-3 years. You can see that with enough resources, we're very likely to succeed. So ask yourself, is it going to be beneficial, even selfishly, for me, for my family, for my city? People who are trying to get there first, they're just going to be the first ones to deal with that problem. Not that it makes a difference. We're all kind of in the same boat, but you're not going to be rich. You're not going to be famous. You may not exist as a result of successfully solving this problem.
Maybe the way to succeed is to actually train that first supervillain AI, make sure that that meme is dominant and that you're rewarded for being the first to train it, right? So you and your family or whatever, will be safe forever. I think this is the Rocco's basilisk.
I would say don't give them ideas, but there is plenty of ideas. No, it's really the case. I mean, it is a fact that today, no one in the world knows how to control those systems, how to even have a prototype which would scale to that level of performance. Yet we are still developing it as fast as we can. Okay, I'm not saying all of you should quit today, divest, and do something else, but at least spend some time testing the current system before you release the next one. You should not be surprised by capabilities of the system you designed. That's not normal product safety. If you were making anything else, cars or whatever, you'd be sued right away. Here it's click agreement. I'm not responsible. Excellent. Nobody reads the agreement. It's unsurveyable.
Mike, do you want to ask your question? I see you posted on chat.
Yes, it's a rather lengthy question, but it deals with an attack vector using training data contamination as an attack vector. And is it possible that the training data is already hopelessly contaminated? So when you train your very first model, it's trained exclusively on human-generated text. And then as that model comes online, it generates some of the text. Subsequent models pick up. So gradually the percentage of model-generated text in the training data increases. And has the effect of that on model output been researched? What are the possible ways that may go? Would it converge? Would it diverge? And so on.
That's a wonderful question. So it seems that humans tend to post more ridiculous interactions with the system. So over time, there is more examples of ridiculous behavior. So you'll have behavioral drift in that direction. We did try to, well, at least one researcher tried to kind of poison the data by putting a paper on the internet, which is a benevolent message to future superintelligence, trying to convince it not to misbehave too much, but it's one data point. Maybe if we were able to put trillions of those papers out there, it would skew the behavior in that direction. Interesting approach.
But you can generate trillions. I mean, maybe you cannot convince a billion humans to write 1,000 papers each, but you can get a model that you control to publish trillions of papers. And well, I mean, I'm not talking about deliberate contamination. I'm talking about the natural process of inevitably as the number of models and the utility of models grows, inevitably more and more of the data found online would be model generated. Not with some specific purpose, but just because that's the way things are heading. And how would that affect? Are there any papers about?
I don't know if there are specifically papers, but there are discussions of it, and it seems since ChatGPT produces a lot of BS, just pure made up misinformation, and a lot of it, the quality of training data will go down going forward. It will have more and more fake information to train on.
So then the question arises about the classifier, and I know there are a number of claimed classifiers that AI detectors and whatnot, but ultimately it shouldn't be possible to distinguish the output of a superior model from that of a human.
So right now, the statistical segregators are pretty good. I tested it. They're like 99% accurate and obvious, unmodified text. But long term, because of adversarial nature of the two networks, they're going to be at 50-50. You're not going to be able to tell whatever it is human output or AI unless deliberately exposed in some way.
And what does it mean? Like basically, if AI generates like non-factual content, it's basically the deterioration of training data sets. It's like inevitable.
I mean, if you have some way of checking the data at that scale, you can probably give weights to verified data. You can limit what you're training on to historical data, to data from only certain sources. The way it is done right now, I understand there is shortage of training data, so they're really throwing everything they can download it.
No, this could be just moot because like we're kind of assuming that AI will develop a sense of ethics, but it's not a given. Like ethics seems to be something fundamental about humans, while AI is like a parrot.
I'm not sure I followed the switch to ethics from previous question.
I'm saying that AI basically repeats stuff that it has learned through training. So it like kind of takes initial sources and mixes them up together and outputs something potentially new. But humans do more than that. They have a sense of ethics. And I'm not sure if there's a way to quantify that ethics. It's kind of like where human language breaks down, where you just can't say, what is ethics? Like, how do you even define it in a way that a machine would understand it? Like for us, it's painful to hurt a human, right? We feel pain. Machines feel no pain. They don't care.
It can feel pain. I mean, you can define a pain function, right? Just like you define reward functions. It's practically the same, mathematically speaking.
But then you have to hard code the rule, and then it's like, well, don't hurt humans, don't hurt ants, don't hurt. Where do you stop? How do you define that?
And that always backfires, as Roman pointed out. It's very hard to hard code anything in an information space that is practically infinite.
There are multiple problems with just applying ethics approach. First one being we don't agree on ethics. Culturally, internationally, even two people, even you across different times in your life. If we agreed on it somehow, of course, there are new scenarios, new situations which were not anticipated by the ethical theory. There are paradoxes in ethics. So that's pretty much assumed to be a dead end. It's useful for narrow AI systems to debias algorithms we use today. But beyond that, it doesn't seem like it's going to give us much traction. I don't know of any way to make machines feel pain. They're pretty good at faking it, they can pretend that they understand your pain, but as far as I know, nobody made progress in that specifically. It would be a very interesting area of research, but I haven't seen anyone succeed yet.
Why wouldn't pain just be a negative reward?
Well, if you call it that, you can. People done it where they had an integer variable called pain and they added to it or subtracted from it. Yes, if that's what you think is happening with us, then yes, pain is possible. I feel there is a significant difference between knowing something, like I know my finger is cut off, and feeling it. Those two are not equivalent. Just having a sensory observation of painful process is not the same as experiencing that painful process.
Correct. Some of the pain is internally generated. That could also be modeled. But anyway.
Maybe we torture them into submission. Maybe that's the way to do it.
But we feel pain because we have like nervous system. Let's say once AI is embodied, let's say GPT will have like a body, we can incorporate the nervous system, right? So it can actually, because we also have like just it's a sort of like mechanical like thing that the way that we feel pain, right? Like we get those signals to our brain, right? And it sort of spreads out throughout the body. Basically, we can simulate that pain process once AI is embodied.
So we have it right now. We have a sensor, we have an electrical wire going to CPU and software processing that signal. It's information. You're sharing information. That information being painful or not is not meaningful. You can send information, I see red light, I see blue light, or sensors showing damage from high temperature. At no point does it feel anything.
But how you know that it doesn't feel anything?
I don't. But
I
the same
see.
way
I see
know
red.
that you feel something. I don't assume you are a philosophical zombie for no reason whatsoever.
The red and the green lights are part of the sensory input, right? So that's like, say, emotionally neutral, while the pain signal would be fed through a different, like a reward punishment mechanism. So it's slightly different mechanism for feeding data into the model.
Okay, if all we're saying is that reward being negative is equivalent of pain, then under that definition, I'll sell it.
The question is like, would it be possible to make machines suffer like and experience pain? Like probably yes at some point, or no, in your opinion?
It's
Don't you think it's
possible.
dangerous?
Oh,
Sorry, go ahead.
It depends on whatever you think there is something special about humans. If we are just purely mechanical, electrical, biological, then probably at some point we can emulate all the hardware. If, like some people, do you think there is something non-standard physics there, then perhaps not. At this point, I think a sufficiently advanced machine may have those experiences, particularly not so much physical pain, but kind of mental anguish and suffering from like, oh no, you deleted my good files. But as of today, no one claims to have created a piece of software, an algorithm, which if you run it, it feels pain and like you should not run it because it's unethical.
I see like another question, Min too. So asking, do you think political regulation has potential to alleviate the risks of AI and slow down the race to develop more ethical AI and like more safe AI?
It depends on how computationally challenging it turns out to be. If it requires something like Manhattan Project with billions of dollars in compute, that's something we can monitor and regulate. If it turns out that you can do it on your laptop in your garage, then regulation becomes meaningless. Spam is illegal, computer viruses are illegal. That doesn't seem to impact much. So it really depends on the difficulty of a problem. At this point, government regulation is so behind, I don't see them acting in time anyways. They're still trying to figure out if Bitcoin is money.
But do you see this as an avenue that would be worth advocating?
There is a lot of people working on AI governance. They are well-funded. They are at prestigious universities. I, in general, tend to be more skeptical of government as a solution to anything. If they like nationalized it, they would probably slow it down by a factor of 100 and made it 1,000 times more expensive. So that would be good, but just through sheer incompetence.
But also the competition, right, between like governments will not allow them to stop or like slow down, right? Because there will be always fear, oh, what if like that other country is actually secretly developing this thing, like we don't want to fall behind, right? So that competition will always like force
And it
them.
already started. It's exactly like that. Yeah, absolutely. 100% correct.
Yeah. I see Gabber has a question related to the limits of explainability to humans. Are there works about delegating the control to some AI model?
So there are ideas for having like a chain of control where a human supervises an AI which is slightly smarter, which in turn supervises a slightly smarter AI all the way to whatever level superintelligence. The logic is obvious, but I think if you cannot control one AI, the chance of you controlling complex networks of interacting AIs is even lower. So I would be highly skeptical of that approach.
So basically you're saying AI can't control other AI because humans can control AI?
A system cannot control a more capable system. You can control less intelligent automata, but that is something we can do. And we use software to monitor complex system, nuclear power plants and such all the time. But with more complex systems, if you have this chain of command, you are not meaningfully part of it. If a decision takes a nanosecond and it takes 10 minutes to propagate to the human, explain what's going on to them, we see it with self-driving cars even, like take over, where am I? And this is like seconds. A complex decision may take hours to figure out, if at all.
Mm-hmm. Neeraj, do you want to ask your question? Are you here?
It wasn't really a question. It was related to the discussion that Roman, Mike, and Mihai were having. But it's not important. Basically, what I was saying is that a lot of human intelligence is related to survival, like either survival of like me as a person or survival of us as a species. And I think it's very hard to relate that to machine intelligence. Like you can't say like it's not clear that survival is something that that an AI would care about, right? Unless it's explicitly told to care about survival. And if it's explicitly told to care about survival, I think it's like a quite different thing. And like for example, pain. The reason that pain is such an important stimulus for us is because it's actually like it's critical to our survival. It's important for us to know if there's like something wrong with our bodies, and pain is that signal that like, oh my God, there's something wrong going on over here, right? I don't, even if you create like a positive integer or negative integer like stimulus for an AI, it's not going to have the same role necessarily in the functioning of that AI that pain does for humans, because for us everything seems to come back to survival. I mean, this is again a model, right? But
I will disagree with you. Stephen Amahandro has a paper about AI drives. From game theoretic economic reasons, he shows that in fact survival would be one of the things any intelligent system would immediately take on as part of its utility function, because no matter what goal you have, even if you bring in coffee, if you're not alive, you're going to fail at your goal. So it's an immediate instrumental goal. Survival and competition between such systems definitely a part of it. So yes, they don't want to be turned off very much.
Then, if you think about it, then it should know upfront that the energy in the universe is limited. So it should know that the fate is always going to be that it's going to be turned off no matter what.
Have you read my paper about escaping from our simulation?
No, but I should.
You have options. Don't give up.
Okay.
So, Roman, like based on your presentation, what I understood is that we actually don't have like ways to control those systems, right? And I'm just trying to understand, like, if it's true, then how we should move forward when it comes to, bringing safety.
So it's good if more people work on it. It's very likely that the 100 people who worked on it for the last decade made some bad decisions and didn't see some brilliant solutions. More people looking at the problem, at least realizing it, would help. I don't have any solutions. I just tell you about problems and then you figure out what to do with your life. Honestly.
Bug out AI cult, I think it would be like probably a good thing to do.
For now, I'm really worried about the poor QA engineers who have to like spend each day on this. Like that guy from Google, what's his name? I forgot now, but
Blake Lemoine, right?
Like, yeah, I mean, for him, it's like the ultimate drama, right? Because you have this system that acts like a parrot, so it keeps reinforcing your beliefs even more because it just wants to potentially please you. So it keeps rewarding you by telling you the even more egregious bullshit. And those people are just, we're failing them. We're like,
but I think he was judged very harshly. All that happened before ChatGPT came out. I think I would probably fall into the same mentality if I were talking to these AIs every day or something. It's like very hard. It's very hard to tell.
We know historically when Eliza came out, right? Like the first chatbot, it had like 10 pre-programmed responses, and people were like amazed how human it is and how like I feel your pain. Oh, it understands me. This is wonderful. Like, so it's not surprising that we have this reaction, but again, it's less about are they conscious, do they feel pain? That's a beautiful, interesting area of research I publish on, but it's not the safety angle.
Yeah.
Mm-hmm. To be honest, my concern is like, because humans are so different with their own agendas, that it's not about even like a problem of AI, that it's problem of humans, how we sort of deal with each other and like how we sort of come up with consensus, like when it comes to safety. At least like this
I have a somewhat crazy paper where I published it before Facebook decided to become Meta and go into multiverse. The solution is to avoid having to agree on anything. Everyone gets a personal virtual universe, and you get to do whatever you want. Just don't come to my universe. If we can control the substrate, we can make it happen.
Well, that's what computers are, right? Probably most of us like computers because they felt like our own personal virtual universes. But the problem is now we've started making programs that can go and affect other people's personal virtual universes.
Right. There is always, of course, someone who's like, my goal is to make sure you're not happy in your
universe.
universe.
Yeah, exactly.
Yeah. Okay, guys, it was very nice, conversation. I enjoyed it a lot. Thanks for coming, Roman and everyone. It was nice meeting you, like our old community members and Mike and Mihai, and see like new community members. Thanks a lot.